One of the most famous, useful, important, prominent relations is an equivalence relation. What is meant by an equivalence relation? If R is a subset of A cross A, where A is a non-empty set, then R is said to be an equivalence relation on A if number one, the first character R is reflexive. Number two, R is symmetric. Number three, R is transitive. R is transitive. That's it. If at all there is any relation which exhibits these three types of character, namely reflexivity, symmetry, and transitivity, then it is termed as an equivalence relation. In our journey, in our discussions regarding all the types of relations, we have observed some relations which are reflexive, symmetric, and transitive also. Such things are called equivalence relations, and now it is our turn to go through those equivalence relations. That is to have the examples of equivalence relations. We're now going to do that. Yes, you please follow the definition very carefully. What is an equivalence relation? It must be reflexive, it must be symmetric, and it must be transitive. No question of any doubt. Yes, that is an equivalence relation. Now, we shall go through some equivalence relations. We have already seen the definition and meaning of equivalence relations. We now go through some examples of equivalence relations. Very first of all, is equal to is an equivalence relation. It is reflexive, it is symmetric, and transitive. And then is similar to, on the set of all triangles, is an equivalence relation. And is congruent to among the triangles is again another equivalence relation. Is similar to and is among triangles is an equivalence relation, and is parallel to is an equivalence relation among it. Well, after that, among human relations, have the same father as, is an equivalence relation. Lives in the same house of, is again an equivalence relation. And of course, by mathematical definitions, we can create so many other relations also. These are the famous equivalence relations which are available. There has been another standard equivalence relation which is to be discussed specially. We now go to that special equivalence relation. There has been a special equivalence relation on the set of integers. It has been defined. What is that? If A comma B belong to Z, then A is congruent to B mod M if and only if A minus B is divisible by M, or M is a factor of A minus B. This is a very beautiful definition on the set of integers. It's not a relation, of course, it is a definition. When can you say that, see, this is written like that and it is read as A is congruent to B modulo M, or simply A is congruent to B mod M. And it happens if and only if A minus B is divisible by M. See, it will be quite clear if you can go through certain example. Like here, 11 is congruent to 5 mod 3. What is the difference between 11 and 5? 6. 6 is divisible by 3. It's correct. 18 is congruent to 6 mod 12. What is the difference? 18 and 6 difference is 12. 12 is divisible by 12. Just like that, look here. 27 is congruent to 7 mod 5. What is the difference? 27 minus 7 is 20. 20 is divisible by 5. Like that, we exemplify this type of definition. This is what we call the congruence modulo M. Yes. And this relation, congruence modulo M, the symbol for this relation is, this is an equivalence relation. This is peculiarly defined as an equivalence relation. You can easily say A is congruent to A mod M. Why? Because A minus A is divisible by M. If A is congruent to B mod M, then B is congruent to A mod M. If A minus B is divisible by M, then B minus C is divisible by M. So it is symmetric. A is congruent to B mod M and B is congruent to C mod M, then A is congruent to C. Yes, of course, it's transitive. Hence, it is an equivalence relation. This is very famous equivalence relation on the set of integers, and it is known as special equivalence relation on JEE.